Men, and I use thermolusely. Hey, welcome back. This is going to be the kind of post-mortem wrap-up on the failed 62CH rebuild. The last video ended kind of abruptly at the end. I said the owner decided to cut his losses on it. So let me just explain a little bit about what went on and what some of the factors were. I got the engine cleaned up, sandblasted, power washed, disassembled the rest of everything that needed to be disassembled, and start taking a look at this thing. Well, it took quite a bit of work just to get it to the point to determine whether or not it was repairable at all. Most of that centered around this weird transmission setup the guy had on here. And I had to somewhat put it back together again just to see if the trans was going to fit correctly and whether or not it could be shimmed correctly as far as the main shaft gears and the counter shaft gears are concerned. And as it turns out, much to my surprise, that worked out okay. But nonetheless, several hours worth of work just to getting it that far. Well, then, you start looking at all the bits and the pieces of it. Well, how the crank pin was shot, the pinion shaft, the sprocket shaft were out around. I stopped counting when I got to 20 cracks. There's probably more like 30 on this thing. I'm finding other cracks all the time on it. As a matter of fact, there are more cracks that I found. There's some cracks around the kickstart boss, which I find particularly concerning. They're going to be difficult to fix if they're even fixable. Well, they're fixable, but time consuming and difficult, But anyway, I called the owner. I kind of explained this all to him, and he decided it wasn't worth messing with. He lives in Arizona. He'd either have to come and get it, or I'd have to. He lives in New Mexico. He'd either have to come and get it, or I'd have to ship it back. So you got another couple of $300 in shipping, and it just gets to the point where it's stupid to continue. I mean, yes, it can be fixed. But why? I'd be into this thing, he'd be into this thing for $5, probably closer to $6 by the time all was said and done. It just made no sense to continue. When you could go out and buy 2 running Sportsters for the cost of rebuilding this one engine, it doesn't make any sense. And I know all you guys think you got a bike that's worth $8. I buy and I sell kind of a lot of them. I mean, more than most people. And it just ain't out there. I've sold some very, very nice bikes for $3,800. I mean, bikes that were nearly perfect. So, they just ain't worth $8. A good example is worth maybe $4. Your typical kind of beat up old example is worth $2,500, maybe $3. And at that point you're in the market for an early 90s Evo Sportster for that money or even less. But anyway, the economics of it just didn't make any sense. Reliability wise, this engine still had the ass end blown out of the right hand crankcase. There's a gazillion cracks in there, little tiny ones, pores, porosity, oil seeping out of there. So in the end you'd end up with a bike that was of questionable structural integrity with an experimental transmission in it. And I'd like to stress here, I have every reason to believe that transmission would have worked, but nonetheless, I had never seen that done with that bearing before. It is kind of a good idea, and it might be something I'd want to look at doing later on if I had to. But anyway, what the owner and I agreed to is this. He paid me a couple $100 for the time I had into it, and said, fuck it, it's just not worth, coming to get the motor, just keep the motor. And, I said, well, okay, I'll keep the motor, it works out for me, it's okay, we'll just call it even. And there are a few parts that are sellable on it, primarily the oil pump and the cams. The rest of it is pretty much not usable. The main shaft, on the experimental transmission was turned down in order to accommodate that ball bearing. So the trans as a unit isn't really worth selling to anybody. It had 2 gears in it, 2 gears on a countershaft that were no good. So, you know, the trans is of little or no value. The flywheels and the connecting rods are of little or no value since all the shafts are no good. The pistons are at oversize. They're no good. The pistons, of course, are no good. The heads are in desperate need of the hardened seat valve job, which, of course, this is all doable, but at a cost. So, you know, the heads really aren't worth anything. The cylinders aren't worth anything. There's just not a lot left in this motor. But what I decided to do was, because I had committed to you guys that I was going to, you know, do a project here, I kept working on it even after he pulled the plug. And I did quite a lot of the welding, and I did some fitting and testing, and following this little diatribe about the difficulties, etc., I put together a montage of the remaining repair jobs. So we'll look at what it costs next, and then I'll show you the montage of the repairs to get it to the point it is now. And just FYI, I got 2 cases over here because this is the original case. And what I decided to do on this thing was, because this side of this case was blown out, what I decided to do was get rid of this and use this as the right case. This right case is much more solid of a case than that right case. So the engine would have been mismatched, and hence the part of the videos about matching the cases and the cylinder bores and all that. Anyway, stay tuned if you want. Don't stay tuned if you don't want. More to follow. Alright, so let's look at what this little project is going to cost. Needs a set of cylinders and pistons. The old cylinders were at the overbore limit. Needs a gasket set, of course. Needs a new crank pin. Needs a new sprocket shaft. Needs a new pinion shaft. The sprocket shaft and the pinion shaft were both out of round. The crank pin obviously was beat to hell. And these are prices for Jim's, and Jim's of course is very expensive, but since one of the generic import sprocket shafts I tried to use broke in 2 a couple months ago, I won't be using those anymore, and I'm going to be buying Jim's. You know, I like to try to keep the rebuild costs low for people, but you know, I'm not taking chances on these import parts anymore. Needs the main shaft. Needs a countershaft low gear or first gear. And needs a countershaft third gear. And these, of course, are for Andrews. And once again, import alternatives are available and are much cheaper. But I learned a long time ago on the trans parts, I don't use import parts in the trans at all. There's one gear that Jim's doesn't make, and it's the countershaft low gear with the spiral drive on it for the Speedos. So if you need one of those, I might have to go with the import version on those. But anyway, the first and third gear had a very weird wear pattern on them, and I attribute that to the countershaft bushing boss or bearing boss on the right hand case not being correctly aligned with the left hand case. I mean, if you were to look at the wear, you could just kind of tell that it was something caused by the gears contacting each other at a slight bit of an angle. Tappets, 4 of them, Timken bearing, valve seats and guides, and these are the cheaper parts. If I wanted to go with black diamond or something, you could probably double or triple that. Okay, main shaft race. The plan B on this one was to swap a right hand case with the existing right hand case so that I could go back to a regular main shaft bearing. So of course I needed a race. Rear motor mount, thrice cracked and welded. Set of used flywheels. One of the flywheels that was in that engine was totally dicked up. Full set of clutch plates. The steel ones were all heat warped. The fiber ones were all soaked in oil. And they were soaked in oil because, of course, the derby cover was missing. These things used to be $4 or $5 a piece, and I used to just throw them away whenever I took an engine apart because they were so cheap. But these things are going for $18 a piece these days, so that ain't cheap. The base price of the rebuild, the extra $150 per head for the heart and valve seats, and you know, originally when I looked at it, I saw the valves obviously were sunk pretty deep in the head. And I thought, well, I'll just use the oversized valves. That'll save the guys some money. I won't have to do the hardened seat deal on it. Well, then I started looking at it close, and turns out it already had oversized valves in it. And, you know, you reach a limit where you can't just keep making the hole bigger anymore. So you'd have to do the hardened seats and start over again. Matching the cases. The right-hand case that I wanted to use was actually in pretty good shape. It was nice, it was flat, everything was good. The left-hand case was severely warped. After I got done sanding the left-hand case down on my surface plate and got it to match, the cylinder spigots would no longer fit in the case because the holes are too small. So I had to prop the assembled case up on the milling machine and mill the cylinder bores to fit the cylinders and get the holes matched up. Anyway, extra $300 for that. And of course, your miscellaneous nuts, bolts, washers, thrust plates, lock plates, etc., etc., etc. So you're looking at $4,900, and that doesn't include any of the labor for all of the additional welding and machining. So you're at $5,000 right now, and like I say, that other cost is not added in here yet. This thing is going to be hitting $6,000 at least. But anyway, that's kind of, you know, geez, you could buy another engine. You could buy a whole bike for $2,500. There's very few circumstances in which spending this much money on that engine is worth it. This is that messed up area on the bottom. I think the last time you guys saw this, it was probably covered with black paint, grease, and oil. Of course, it's been power washed, sandblasted, and somewhat cleaned out. I think you did see it after that. But anyway, here's that big crack that ran through here. This thing was oozing oil and gushing a lot. I had to deeply, deeply valley this out and groove it out to the point where I had gone all the way through the crack and I could see daylight on the bottom of this thing. So it was severe, but I got good flow on the weld. Got all of the inclusions and stuff that the oil would cause out of there. But anyway, this part of this weld is good. And I was starting to fill, I just want to fill all of this in and lay beads across it. And I got a little bit started over here. You can see there's bubbles and stuff in it. I'm going to have to grind over that and do it. As this metal was getting hot, oil was oozing out of the case over here. There's a crack over here. Oil's oozing out over here. There's another crack. A little oil is oozing out over here, so there's another crack. All right, so let's take a look at this. I had to stop welding at least 15 to 20 times to clean out soot that blew out from voids and you know, contaminated the weld. I probably got 4 hours in this, maybe 5, and I got 1, 2, 3 of the 20 weld repairs that need to be done, kind of done. This isn't completely done. Spent the better part of 2 days welding. This is that area that was all broken out. Many passes here. Every pass exposed another void and another crack, and oil was just oozing up out of this thing. I'm pretty confident that I've gotten down to the base metal in all the areas I needed to. Got a lot of welding in here. As I'm welding this side, cracks are opening up on the outside. It was like it was never ending. This crack opened up on the other side, so I got it welded on both sides. Got the missing material around the stud replaced. This is the right side of the crankcase. It is not the right side that came with this left side over here. This is a case out of another engine I had laying around, and the left side of that one was all jacked up. This is fairly jacked up too. Okay, this countershaft boss is cracked. I'm going to have to bore this out, weld the repair section in, and rebore this hole. The big advantage of this case is the ass end of the case hasn't been blown out and welded in. So this is all virgin solid metal. And this is a fairly stressed area in here, so you want this all to be good. On the other case, there were still cracks showing down in here. You know, there was porosity, there were cracks on the inside of the case from the weld job. Just not a desirable piece of metal to have. The other thing I'll show you is this. This area in here was damaged on the other case, and it was also damaged on this one, because they all get damaged here. This is a really weak area. This is a bull hole. Underneath all this welding is an alignment hole for the alignment pin. It was all cracked. It was cracked through here, cracked down in this area. So built it all back up with weld. Of course, heated coil and a re-drill for this. The speedo drive hole is plugged and welded solid. All right, let's catch up on this project. The welding on the crankcases, except for the countershaft boss, which at this point I regard as a minor repair. The welding is 99% done. I got a couple areas I got to touch up, but all the cracks, I think I got all the cracks I could find are done. After I got done welding it, the welds that were on the mating surfaces I milled off and laid it on a surface plate. I was checking to see how flat it was. And as it turns out, the left case was warped. I should have checked this all before I started working on it, but I didn't. So anyway, I find out the left case is warped. And warped kind of a lot, maybe 10,000ths of an inch. It was rocking back and forth. The high spot was in the middle. And that forced me to lap it flat on my surface plate with sandpaper, double-sided tape stuck to the surface plate. I got a 12 by 18 granite surface plate, and I spent a couple of 3 hours flattening the left case. The right case, which is not really part of this engine, I'm mixing years together here. The right case was really pretty flat, so no problem with the right one. A couple of quick swipes and boom, it was ready to go. And I think I mentioned previously, one of the problems that you could have when you start lapping cases or sanding cases to get them flat is they get narrower. And sure enough, the problem now is I've got this cylinder that won't fit in the hole anymore. The front one's okay, but the back one won't fit. So I'm going to have to mill out the cylinder spigot bore. One of the other problems a guy can encounter when you've been sanding cases flat and removing material from them is the flywheels will no longer have adequate free play. My experience has been is that there's more room on the left side of the case than on the right hand side of the case. If I were to put flywheels in this thing right now, I would suspect they would rub heavily on the right side. I'm concerned about that, obviously, but not real concerned. What I plan on doing, and I have done before, and I've seen done by other people on other engines, is I'm going to shim the Timken bearing out and move the flywheels a little bit to the left, and I think that will take care of that problem. Interestingly enough, these problems were not anticipated, nor were they calculated in the estimate I gave the customer. And as you heard from the previous video, he had decided to pull the plug on this thing. Good for him. Smart move. Stupid move on my part to try to resurrect this thing because it really is beyond saving. And at this point, I'm into it just because I want to see if I could make it work. It should be, it should be a decent engine. The new welds are solid. The cases are going to be flat. I know how to compensate for the problems I'm going to have with it. And the immediate problem I have with it is, of course, I have to be able to get the cylinders to fit in the engine. So we're going to go out to the dirty shop. I'm going to show you the rather sketchy setup I have for doing this, and we're going to bore these out. I did a couple of preliminary measurements, and it looks like I got to take about 10 thousandths out of here. In the world of Sportster crankcases, that's kind of a lot, but not really. I've seen some big bore strokers that really, really push the limit. I mean, they get these walls down here to just, 50 thousandths thick, and, that's, I think, really dangerous, but some guys do it. Anyway, out to the dirty shop. We're going to bore these holes out to accommodate the cylinders. And in case you don't realize what's going on is, you got a round hole, okay? Well, when you remove metal from the edges of the hole now becomes an oval. And the widthwise part of it, from one side to the other, is the part that really won't fit. The other dimension, the other dimension, crosswise dimension, is basically okay because you're not changing this to this, you're changing this to this. But anyway, we're going to make it round. Now, normally you wouldn't have to do that, but since I am swapping another crankcase half that doesn't necessarily match the original crankcase half, this is something that you might have to do anyway, because very often when you mix and match crankcases, you'll run into a problem where the spigots are not aligned, and you have to make them straight. So I've done that before. I'm going to do it again. I'm going to show you the setup, and we're going to do this one. All right, here's the setup on the milling machine. We're going to clamp the crankcase to the steel block, which is clamped to the mill table. When I get the crankcase in here, we're going to level the decks for the cylinders, and then we'll be able to come down with the boring bar. It's actually a fairly simple operation. Okay, the crankcase is bolted to the steel block. The block is clamped down, the crankcase is clamped down. It's got a machinist jack to keep it level. Anyway, we're going to use the LED centering tool here to center this thing up. What's going to do is we have function on the air center. Got the upside down, go for Y. Oh, I'm on trail. Ooh, gotta make it early. Okay, X and Y are locked down on 0. Let's put a boring head in there. Working good. All right, we're going to take a measurement on that. There's one area right here that's not cutting. That could either be because I'm off just a little tiny bit, or it could be because these cases are just slightly mismatched. But yeah, that looks real good. And I got maybe another 5 thou to go. All right, I just went and double checked my measurements, and we're good right here. All right, fresh from getting the deck board. Perfect. Front one. Perfect. Okay, here's the finished bores. And I don't know how much of this you could pick up on the camera, but this side, well, and you can't pick up any of this side, but this side and this side were barely cut at all. And that's because if you remove material from the mating surfaces, this diameter does not really change. This is the diameter that changes. So this is the same on both sides. Barely any material removed from the front and the back. Most of the material was removed from the sides. So very good finish, very happy with that. This is pretty much the way I expected it to come out. Barely cut anything on these sides. Most of the cutting was done on the opposite sides. That's what you would expect to happen. This is the left-hand case that I've been welding on and repairing. The trapdoor is bolted in, all the bolts are in, all the bolts are tight, and the dowel pins are in. We're going to center find off of the counter shaft bearing boss. So let's do that now. And I'm just going to use the arrow to find the center of this hole. Alright, Y is locked down. Let's get the X. Okay, mill table's locked down on 0 on the center of this hole. What we're going to do now is we're going to bolt the other crankcase half to this. The alignment pins are in on this half, so we'll get the other case half bolted on. Fucking dumbass, forgot to turn the camera on. Anyway, everything is set up. The case is bolted, the right case is bolted to the left case. It's all clamped down in the table. It's centered on the counter shaft boss on the trapdoor. It is off center of this hole, but this is not the matching case, and that's the kind of thing that could happen when you don't use matching cases, matching trapdoor and such. It could be off center. Anyway, I plan on boring this hole about 50 thousandths bigger than it needs to be, so when I put the dummy counter shaft in to check the alignment while I'm welding it, I'll be able to make up for a little bit of off center here, so I'm not concerned about that. But anyway, I got a lot of material to remove, so let's just keep on cutting. Let's take another we're going to take it off in big hunks here because we got a lot of material to remove. Let's see, I'll go 40 thou. Go another 40 thou. Anyway, y'all got the idea. You don't need to see me bore, another half an inch of material out of here. I'll bring it back when it's close to done. All right, I think I'm going to make 2 more passes. I'm just a little under 2 inches. So I'm going to do a 30 pass right now. I'll take 30 out of it. You know what? Let's take 20. I'm getting close. Let's see where we're at. Well, we're right at 240. I think I'm going to leave it right there. Alright, so here's the bored out hole for the repair section. The repair section is going to go in here. I want to be able to pick a weld up between here, here, and here too to give it a little extra stability. And this is the final result of the repair section. Welded in, ready to go. That weld's a little sloppy, but I've got good deep penetration on it, so I'm happy with it. This hole has not been bored to the final size or the final location, quite simply because I don't know where this case is going to end up. And if I bore a hole now and match it to what's over there, and then I switch trapdoors or switch cases or use this on another engine, it won't line up. So I'm not boring this out. That I don't regard as a big deal. So anyway, final repair on the weld job right there. Okay, and here's the inside, of course. I did get a weld here, and a weld here. This does clear the low gear. If you look close way down in there, you could see the penetration. It doesn't come through all the way. I would have liked it to come through all the way, but it doesn't. But it still is pretty deep in there. So I got a lot of weld on the outside, some weld on the inside. It ain't going to leak and it ain't going anywhere. But anyway, this is the final result. I'm happy with it. It'll be good. I'd like to thank at this time my supporters and my Patreons. I've got 30 hours of labor in this case that's unreimbursed. I did that just expressly for the purpose of making this video. So, you Patreons make these kinds of things possible. It kicks a few bucks back in to replace lost revenue on a project that was not going to go anywhere. So thank you all very much. I really appreciate it. So anyway, that pretty much concludes this project. I'm going to stash these cases in a corner somewhere. I don't know, they bits and pieces of them. They might be good for emergency spares. I just don't know what I'm going to do with them. They're going to be sitting around. I got these two, and actually I got another one over here. And something interesting I found out. This engine over here is a 1000cc engine. A 1000cc right case will fit on a 900cc left case. So I could make a bike that has VIN numbers and for all intents and purposes is a 900cc motor, but actually have it be a 1000cc motor. And I might build that just to do it. The bolt patterns on the cylinder bases are of course different. The differences are in the studs that are on the right side of the case. So a guy could once you match the bores out, bolt the cylinders on and not have to move any studs around. So that might be a fun project for when and if I ever get caught up on everything else. And with that, I am out of here. But you know what I'm always going to say? Get yourselves a coffee cup. Get yourselves a new sticker. See the links down below. Catch you next time. I got more projects coming up. I got a 52K I'm going to get to one of these days. I got another motor on the way here. And I got a whole bike on the way here. So many projects coming up in the next 6 or 7 weeks. I am out of here. Thanks for watching. Bye.